Apply collision theory. According to collision theory, the rate of a chemical reaction is directly proportional to the frequency of effective collisions between reactant particles. For a reaction to proceed, the reactant species must physically collide with one another. Analyze the molecular effect of increasing concentration. When we increase the concentration of hydrogen ions, H to the power plus, we are adding more H to the power plus particles into the same volume of solution. This higher density of particles means there are more H to the power plus ions available to interact with the other aqueous reactants. Consequently, the frequency of collisions per unit time between the H to the power plus ions and the ClO to the power negative ions must increase. Evaluate the relationship between concentration, the rate constant, and activation energy. Activation energy, EA. This is the minimum kinetic energy barrier that reactants must overcome to form products. It is determined entirely by the molecular structures of the reactants and the specific chemical bonds being broken and formed. It is not affected by the concentration of the reactants. Rate constant, K. The rate constant is a proportionality constant that relates reactant concentrations to the reaction rate. Its value is governed by the Arrhenius equation. K equals AE to the power EA/RT because the temperature, T, of the system is held constant in this scenario. The value of the rate constant K remains completely unchanged. Conclude the correct option. Because increasing the concentration of H to the power plus only increases the collision frequency of the reacting ions without altering the chemical pathway or temperature of the system. Option C is the correct answer. The correct answer is option C. The frequency of collisions between H plus ions and ClO ions will increase.